This problem says calculate the work done on a 1500 kg elevator car by its cable to lift it 40 meters at constant speed, assuming average friction average is 100 newtons. What is the work done on the lift by the gravitational force in this process? What is the total work done on the lift? Okay, so the cable car is lifted 40 meters. So there's the tension, here's the friction force, and here's the weight. V is constant, and the displacement is 40 meters. Okay. All right, so since the elevator is moving at constant velocity, the net force on it is 0. And what we're doing is we're using that as the positive direction for the axis. The net force is mass times acceleration, and acceleration is 0, so this is 0. So T minus the friction force minus mg is equal to 0. This is positive. These have negative y components if you want. Okay, so T is F, the friction force, plus the weight. Now the work done by tension. So this is part A, is tension times D times cosine 0. The angle between the tension and the displacement is 0 degrees. Theta is 0 degrees. So this is cosine 0 degrees. All right, so the tension is F times F plus mg times D times, and cosine 0 is 1. So this is the work done by the tension force, and this is equal to 100 newtons plus 1500 kgs times 9.8 meters per second square. Times 40 meters. All right, so this works out to so 100 newtons plus 14,700 newtons times 40 meters. Okay. So 5.92 into 10 to the power 5 joules. So that's the work done by tension. We'll calculate the work done by the gravitational force. We need, let's add a page below. So there's the displacement 40 meters up. Mg is the force acting in this direction. The gravitational force, and the angle between them is 180 degrees. So the work done by gravity is the force of gravity times the displacements times the cosine of the angle between them. So this is mg, the magnitude of the force, times displacement times cosine 180 degrees. And cosine 180 is minus 1, so minus mgd. Okay, so it's 1500 kgs times 9.8 meters per second square times 40 meters. So work done by gravity is minus 5.88 into 10 to the power 5 joules. See, what is the total work done on the lift? So now we have the work energy theorem which says the net work done, which is the work done by all the forces acting on the object, shows up as change in the kinetic energy of the object. Now the object is moving at constant velocity, so the final kinetic energy is the same as the initial kinetic energy since the velocity is the same, and this is 0. So the total work done, which is the work done by gravity, work done by friction force, and work done by the tension, they all add up to 0. Okay, I think that finishes this problem.